So children, as we have learned in our previous part, an atom loses or gains electrons usually to become an ion. This ion gets a charge. It attracts another, or you can say oppositely charged ion to form a molecule. Now this molecule is a molecule of any compound, molecule of NaCl. So if Na loses electron, Cl gains electron, and they combine to form a, so Na is losing electron, so it's becoming a positively charged ion. Cl is gaining electron and it's becoming a negatively charged ion. So now the presence of these opposite charges ensures that there is a physical attraction between the two ions, hence they form a molecule. So this does not happen in all cases, but generally for some compounds this is how the reaction takes place. So we can say that a conversion of an atom to an ion is a chemical process. Why is it a chemical process? Because losing or gaining electron is a chemical process. This is a chemical activity. When you lose electrons or gain electrons to complete your last shell, or to have 8 electrons in your outermost shell, or we can also say to have a complete valence shell, or to get the valency, or to get the electronic configuration of your nearest noble gas. And when two ions attract each other, it's a physical force. It's called as an electrostatic force of attraction, and this attraction between them is a completely physical activity. So you should know the difference between chemical stability and physical stability. So looking at an atom initially, it is electrically stable. That means it does not have any charge. That means it has the same number of electrons and same number of protons. It has neither gained nor lost any electrons. However, it wants to complete its octet state. That means it wants to have 8 electrons in its outermost shell, correct? So for doing so, it loses or gains electron, and hence it gets a charge. When it loses electrons, the number of electrons reduces, the number of protons remains the same, so there are more protons. So when electrons are lost by an atom, it becomes a positively charged ion, and when electrons are gained by an atom, it becomes a negatively charged ion, and then they attract each other, form a physical bond, and turn into a molecule. So this molecule that is formed, this molecule is both electrically and chemically stable. Why is it electrically and chemically stable? Because first of all, the ions, they have lost or gained electron to become chemically stable. Then the charges also neutralize each other, charges of the ions neutralize each other, and a molecule is always and always electrically as well as chemically stable. That means it does not have any charge. Alright, so do you know any atom which is electrically as well as chemically stable? Yes, they are atoms of inert gases. Atoms of inert gases have a complete octet, isn't it? So they have a complete shell. So they do not need to lose any electrons, neither gain any electrons. They are already stable. They are electrically also stable, and chemically also they are stable. So what is our octet rule? Octet rule tells us that every other substance or every element except noble gases, they always combine with each other. These elements, they combine with each other because they have an incomplete valence shell. They only combine because they have an incomplete valence shell. And I think you have understood, because of the incomplete valence shell, they try to complete it. While trying to complete it, they get a charge. Opposite charges attract each other, and then they form a molecule. So the reason for forming chemical bonds is also your octet rule. So reason for forming chemical bonds is also based on the principle of completing your octet state, or completing your valence shell with 8 electrons. All right. So we also know one thing. So now that we have studied so far, we know this, that atoms and ions are very different from each other. So for example, I have given you 2 examples. First example is that of sodium. Sodium chloride. Sodium chloride is one of the most stable combination, or the most stable molecule. So let us look at sodium and chlorine, and sodium ion and chloride ion. So sodium atom, that means a part of an element sodium, that is silver in color. But sodium ion is colorless. Same when we look at chlorine. Chlorine exists in a form of gas, Cl2. Cl does not exist freely in nature. We will come to that reason a little later. But Cl2 as a gas, it's a molecule of an element itself, so that has a color. Cl2 has a greenish yellow color, sometimes greenish brown color, but chloride ion, that is Cl minus 1, that does not have any color. Then when we look at toxicity, sodium is toxic, sodium ion is non-toxic or non-poisonous. When we look at chloride or chlorine, chlorine is again a poisonous gas, but chloride ion is non-poisonous. But the main thing, the main difference that you need to understand is that chemical activity of sodium atom or chlorine atom is very high. Why is it high? Because sodium has electronic configuration of 281. So it does not have a complete octet. So what does it do? It loses one electron and it gets a configuration of 28. Now it has become chemically stable. But before getting chemically stable and forming a sodium ion, when it was a sodium atom, it was highly reactive because it wanted to anyhow lose its outermost electron, one electron in its outermost shell. What about sodium ion? Sodium ion is chemically stable. That means it will not undergo any other chemical activity, which means that it will neither take more electrons nor gain more electrons. Coming to chlorine, chlorine again has electronic configuration of 287. So even chlorine does not have a complete octet. It just needs one electron to get the electronic configuration of 288. Correct? So it will gain that electron and become a chloride ion. So chlorine atom is highly reactive, or it has high chemical activity because it wants to complete its octet. But chloride ion, it is completely chemically stable. Coming to electronic charge, sodium atom does not have any charge, but sodium ion has a positive charge. Chlorine atom does not have any charge, but chloride ion has a charge. So when we talk about electronic or electrical stability, an atom is electrically stable, but an ion is electrically unstable. Hence they participate in the physical combination, which attraction is called as electrostatic forces of attraction, when they form molecules from their ions. All right. Let us now talk about valency. We know what are valence electrons. Valence electrons are the number of electrons which are present in the valence shell. What is a valence shell? Valence shell is your outermost orbit or outermost shell. Now, whenever I have a fixed number of valence electrons, any which ways I am going to have less than 8 electrons in my outermost shell. So when I lose certain number of electrons or gain certain number of electrons, that is called as valency. Many children get confused between valence electrons and valency. They are not the same. Sometimes their numerical value may be same, but they do not mean the same thing. Try to understand, valence electron is the total number of electrons present in the outermost shell. Valency is the number of electrons exchanged or number of electrons donated or accepted to get an octet state. Let's take an example of sodium again and chlorine. So sodium has 281 electronic configuration. How does it get its chemical stability? By losing one electron from its outermost shell, it becomes 28. Same, let's talk about chlorine. Chlorine, so sodium has how many valence electron? 1. It had only 281. So valence electron is 1. How many did it lose or gain to get chemical stability? 1. So valency as well as valence electron of sodium is the same, which is 1. But when we look at chlorine, chlorine has atomic number 17. Its electronic configuration is 287. So what is the number of valence electrons for chlorine? The number of valence electrons for chlorine is 7. But what is the valency of chlorine? The valency of chlorine is 1. And that is because of its having 7 electrons in its outermost shell, because of having 287 electronic configuration, it needs 1 electron. It needs only 1 electron to attain its octet state. So what is valency? Valency is the number of electrons taken or given to get your chemical stability. So how many electrons does it gain or lose? It gains 1 electron. So what will be the valency of chlorine? It will be 1. What will be the valence electrons of chlorine? It will be 7. Let us take an example of magnesium. Magnesium has electronic configuration 282. So how many valence electrons does magnesium have? Magnesium has 2 valence electrons. And what is the valency of magnesium? Magnesium loses 2 electrons to get the electronic configuration of 28. So what is the valency of magnesium? It's 2. But let's take an example of oxygen. Oxygen has electronic configuration 2,6. So how many electrons does it need in its last shell? It needs only 2 electrons in its last shell to get an orientation or get an electronic configuration of 2,8. It was 2,6. So it will gain 2 electrons and it will get the electronic configuration of 2,8. So how many electrons is it gaining or losing? It is gaining 2 electrons. So what will be the valency of oxygen? Valency of oxygen will be 2. What will be the valence electrons of oxygen? 2,6. So what is the number of electrons in its outermost shell? 6. So do not get confused between valence electrons and valency. Now certain things you will have to remember now that we are moving on to the chemical bonding part. Now we have seen how atoms are formed, ions are formed from atoms, and now we will see how these ions combine, or maybe sometimes they do not form ions. So you should know what are some certain things that goes on for an atom. Certain atoms lose or gain electrons. They do exchange electrons. Like metals, they have a tendency of losing electrons. Non-metals have a tendency of gaining electrons. But there are certain substances which have 4 valence electrons. Carbon, silicon, they have 4 valence electrons. So they have to either lose 4 or gain 4, both of which are going to be very, very high energy consuming activities, because gaining 2, 3 is still fine, but gaining 4 or losing 4 is really difficult task. It really requires a lot of energy. So what do they do in those cases? In some cases, atoms also share electrons. That means atoms can convert to molecules without forming ions. They can just mutually share electrons. Sometimes it also happens that an atom has some extra valence electrons. So it shares through a one-way path. That means atom of one element is the one which is sharing all the electrons in the pair. So all this may sound very confusing to you. So let us start with all the types of chemical bonds, and it will get very, very clear what are the types of bonds and what happens to the electrons. Because electrons are our hero here. They are the ones who are either getting exchanged or getting shared in any manner. So those electrons are the ones who are going to decide what is going to be the type of bond between the two atoms of two different or same elements. So let us start with our chemical bonding. Okay children, so now let us look at the types of chemical bonds. What are the main 3 categories of chemical bond? Let us look at that. So the first type is the one that we have been studying about giving electrons, taking electrons, ions are formed. These ions, oppositely charged ions, attract each other and form some bonds. So the bonds formed by the mutual attraction of ions or attraction between oppositely charged ions is called as an ionic bond. There is another name for it. It is also called as an electrovalent bond. Why is it called as an electrovalent bond? Because it has some electrons exchange that has taken place, and because of this electron exchange, charges are also exchanged, and hence they can attract each other by electrostatic forces of attraction. Alright, this is the second type of bond. The second type of bond that we are going to see is a covalent bond. A covalent, co means some kind of sharing is going on. So a covalent bond is a bond which is formed by those atoms which cannot or not readily giving or taking electrons. They are not ready to give electrons. Like for example, if we talk about hydrogen. Hydrogen usually it just has one electron. So if it gives away its electron, it will practically become a proton. It only has one electron and one proton. The isotope of hydrogen which is commonly found has only one electron and only one proton. So if it gives away that one electron, it completely loses character of an atom. It becomes a proton. It practically becomes a proton. So it's very difficult for hydrogen to lose electrons. Talking about carbon and silicon. Carbon has 4 valence electrons. Silicon also has 4 valence electrons. So it's very difficult to lose 4 electrons. Takes a lot of energy. Same, it takes a lot of energy to gain 4 electrons. So they also like to share electrons. Some atoms like hydrogen has characteristics of both metals and non-metals. So hydrogen shows characteristic properties of both. But when hydrogen combines with a non-metal, when hydrogen combines with a non-metal like oxygen, like chlorine, like bromine, these type of bonds are covalent bonds, because neither non-metals are ready to give electrons, isn't it? Non-metals want to take electrons. But when non-metals are in the presence of hydrogen, hydrogen also wants to take electrons. So what do? They come to a mutual understanding that we will share electrons. How they share it? We will come to that a little later. The third type of bond is a coordinate bond. Coordinate bond is a very special bond. So those type of bonds where sharing is happening, but the pair of electron is provided only by one atom. One atom provides both the electrons. So those type of bonds are called as coordinate bonds. Covalent bonds are also called as molecular bonds, because without forming ions, they directly form molecules. Coordinate bonds are also called as co-ionic bonds. Co-ionic, why? Because they have properties of both covalent bonds as well as ionic bonds. Is that clear? So a very good example of your ionic bond is NaCl bond. If you can see, Na loses electron, that electron is accepted by Cl, they become ions, they get charged and then they attract each other. A very good example of covalent bond is formation of chlorine molecule. Chlorine molecule, so 2 chlorine atoms, neither of them are ready to give electrons, so they share 1 electron with each other, 1 electron each, so their octet can get completed and they form a covalent bond. What is an example of a coordinate bond? Coordinate bond, hydronium ion, H3O plus. Okay, it's a complex ion. Then we can talk about ammonium ion. NH3 is ammonia, but NH4 plus is ammonium. These type of bonds which has a charge as well as sharing of electron taking place at different spots between different atoms of that bond, that type of bonds are called as coordinate bonds. So we are going to, so this can be a little confusing in the beginning, but as we proceed with the lesson, as we proceed with the chapter, you will get a clear idea about all types of bonds. So children, let us understand the first type of bond. The first type of bond is very easy. This is a bond which is formed between metals and non-metals. Why do I say that this is a bond which is formed between metals and non-metals? Because metals usually donate electrons. Calcium, magnesium, sodium, they are donators of electrons because they have 1, 2 or 3 valence electrons only. That means they have 1, 2 or 3 electrons in their outermost shell. What about non-metals? Non-metals are acceptors of electrons. Why do they accept electrons? Because they have 4, 5, 6, 7 valence electrons. That means they have 4, 5, 6 or 7 electrons in their outermost shell. So they will accept electrons to complete their octet. Coming to valency. Valency of metals is also 1, 2, 3, but valency of non-metals is also 1, 2, 3. Why is that? Because valency is the combining capacity. Valency is valency is not the same as valence electrons, especially when we talk about non-metals. You can see the valency of metals is 1, 2, 3 because it will lose 1, 2 or 3 electrons. But valency of non-metals is also 1, 2, 3 because it will gain 1, 2 or 3 electrons. Coming to ions, metals form positive ions. That means they form cations. That means they form basic ions. So these 3 are the names of positively charged ions. Basic ions, positive electropositive ions, basic ions or cations. What about my non-metals? Non-metals form negatively charged ions, or we can say electronegative ions, or we can call them acidic ions or anions. Alright, this is the general tendency. Coming to electronegativity, electronegativity of metals is very low. That means electronegativity, that means the tendency to gain electrons in metals is very low. Coming to non-metals, electronegativity is high because electronegativity is the tendency of gaining electrons. So electronegativity is very high when we talk about non-metals. What is electronegativity? Let us see. Electronegativity is the tendency of gaining or accepting electrons and becoming negatively charged ions. But this definition of electronegativity is incomplete. Electronegativity's definition will be complete after we study our covalent bonds. So children, now that we are in the topic of electrovalent or ionic bonds, that means we are exchanging electrons, we are literally giving out electrons or taking electrons. Alright, 1 electron, 2 electron, 3 electrons. So electrons are involved here. So when electrons are exchanged, we see a kind of an activity which we call as oxidation or reduction. This is a small concept which is not exactly related to the topic of chemical bond, but you should understand what is oxidation and what is reduction, because most of the reactions that we see, most of the reactions, chemistry is all about reactions, and most of the reactions we see are going to be redox reaction. That means they are going to be a combination of oxidation and reduction. Now what is oxidation and what is reduction? What are these complicated terms? So one very easy way to remember oxidation and reduction, what exactly it means is, you can remember the word oil rig. Oil rig. Alright, so oil means oxidation is losing and rig means reduction is gaining. Now here if you make the mistake and you say oxidizing is losing and reducing is gaining, it will become the complete opposite. I'll explain it to you in a short while. First let us understand by the principle of oxidation is losing and reduction is gaining. That means oxidation is losing what? Electrons. Reduction is gaining what? Electrons. So the activity in which we gain electrons is reduction. The activity in which we lose electrons is oxidation. So who undergoes oxidation? Yes, metals undergo oxidation because they lose electrons. Coming to non-metals, reduction is losing. Losing what? Losing electrons. So when a substance gets reduced, that means it is gaining electrons. Alright, rig. So metals or non-metals are gainers of electrons or acceptors of electrons? Yes, they are non-metals. Non-metals usually gain electrons. So who undergoes oxidation? Metals. Who undergoes reduction? Non-metals. But not always exchange of electrons takes place, right? So sometimes we also have to define it by its classical terms. That means oxidation. What does the word mean? Means addition of oxygen, that is oxidation. So whenever oxygen ion gets added, oxygen ion, that is oxide O2 minus, whenever that gets added to any other ion, we call it oxidation. Similarly, if oxygen is not present, if instead of oxygen you have any other electronegative ion like Cl minus, or you can have S2 minus, you can have Br minus, you can have many negative or electronegative ions. So in the absence of oxygen, addition of any other electronegative ion is also called as oxidation. And as opposed to gaining oxygen, when you lose hydrogen, let's say I am not able to gain any oxygen ion, that is O2 minus, or any other electronegative ion. In that case, losing hydrogen ion, that is H plus ion, or losing any other electropositive ion like losing Na plus, losing Mg2 plus, losing Ca2 plus, losing electropositive ions or losing hydrogen ion is also called as oxidation. So what is oxidation? Oil, that is oxidation is losing electrons, oxidation is addition of O2 minus ion, that is oxide ion, oxygen is addition of any electronegative ion in the absence of oxygen, oxygen is removal of H plus ion, or oxygen is the removal of any electropositive ion. Similarly, what is reduction? Reduction, RIL, that is oil, RIG, oil rig, RIG. So reduction is gaining. Reduction is when you gain electrons, and it is the exact opposite of oxidation. So it should be very simple for you. Reduction is losing oxygen or oxide ion. Reduction is also losing any electronegative ion. Reduction is gaining H plus ions, or reduction is gaining any electropositive ion. So this is the basic difference between oxidation and reduction, and if you know these 4-5 principles which defines oxidation and reduction, you should be able to find out what type of, which reaction falls under oxidation, which reaction falls under reduction. So going by this, let us take a few examples. For example, we are looking at the formation of sodium chloride. So sodium has electronic configuration of 281. Now we have been repeating it many times, so we know sodium loses electron. So one atom of sodium will lose one electron and become sodium Na plus ion. That's a cation. What happens to chlorine? Chlorine gains one electron and it becomes a electronegative ion. So chlorine gains one electron because its electronic configuration is 287. It gains one electron and becomes 288, and that's how it becomes a chloride ion. So now we are looking at the formation of sodium chloride. So sodium ion is positive, chloride ion is negative. They have already undergone their chemical activity. Now they are going to attract each other by the help of which force? Yes, it's a physical force called electrostatic force of attraction, and it will form a NaCl molecule. Remember this, two ions attract each other and form a molecule of a compound. So another example, you can look at the formation that I have shown you over here. Sodium plus chlorine forms sodium chloride. So when you have to see the conversion of sodium to sodium chloride, that conversion is what? Sodium, something is added to sodium. What is added to sodium? So, chloride ion is added to sodium. So addition of an electronegative ion. What does that mean? Oxidation. Same if we look for chlorine. Chlorine got added with sodium. After the reaction took place, chlorine became sodium chloride. So addition of electropositive ion. So what does that mean? That means it has undergone reduction. So can you see oxidation? Sodium has undergone oxidation, chlorine has undergone reduction. So it's a redox reaction. So coming to the next example, Mg plus Cl2 gives me MgCl2. Now Mg to MgCl2. So what happened here? Mg was whatever Mg was, it got added with chloride, which is an electronegative ion, and getting an addition of electronegative ion is called as oxidation. So sodium has undergone oxidation. What about chlorine? Chlorine has undergone reduction. Why? Because addition of sodium happened to chlorine, and sodium is an electropositive ion. Similarly, we can see another example. We can look at formation of calcium oxide. Calcium oxide is calcium plus oxygen gives you calcium oxide. So calcium is undergoing what type of state change? It is undergoing oxidation, because calcium के साथ कौन add हो रहा है? Oxygen, which oxygen ion is a electronegative ion. What is happening with oxygen? Oxygen cannot add with more oxygen, right? Oxide is electronegative. Electronegative will get added to electropositive ion. So what is oxygen undergoing? Oxygen is undergoing reduction. There is one very important thing that we have to understand here. If I undergo oxidation, that means I have lost electrons. So those electrons will be gained by someone. So I, by getting oxidized, become a good reducing agent. Once again, I'll repeat this for you. This is a very important concept. So when I lose electrons, I get oxidized, but those electrons will be gained by someone. So the person who is gaining those electrons is getting reduced. So can I say by getting oxidized, I lose electrons, and by gaining those electrons that I lost, another substance gets reduced. So can I say by getting oxidized, I become a good reducing agent? Similarly, substances that get reduced, that means substances which gain electrons. When they gain electrons, they are gaining it by removing electrons from someone. That means chlorine can gain electrons theoretically we can say by gaining electrons from sodium. Chlorine can gain electrons from sodium. So sodium lost electrons, it got oxidized, became a good reducing agent, and by chlorine gained electron, got reduced. So can I call it a good oxidizing agent? Because it attracts electrons, it removes electrons. So gaining electron by removing it. So gaining electron is called as reduction, but removal of electron is you become a good oxidizing agent. So remember, substances which get oxidized are good reducing agents, and because they provide electrons, and substances which get reduced are good oxidizing agents. And the best tip is metals get oxidized and are good reducing agents, and non-metals get reduced and are good oxidizing agents. So children, now that we have seen how an electrovalent or an ionic bond is formed, let us look at some of the important characteristics like a recap that we have already studied. Okay, so electrovalent bond or ionic bonds are formed by ions. It's formed by a physical force of attraction between these ions. What is that force called? It's called as an electrostatic force of attraction, or we sometimes also call it Coulomb force. Coulomb force exists in between them. So this is a completely physical force. Remember this. How are these ions formed? Ions are formed by exchange of electrons. Cells are givers of electrons, they donate electrons, and some elements like non-metals, they take electrons. So when they give or take electrons, only then an ionic bond is formed. Then we are coming to hydrogen. When hydrogen combines with metals, like for example, if we talk about NaH, or we can talk about CaH2. What are these compounds? NaH is sodium hydride. Alright, then we are talking about CaH2, that is calcium hydride. Similarly, potassium hydride, that is KH, is also formed. Here you can see that the metals are in the front, that is cation is written in the start and anion is written towards the end, which is KH. So H is the anion part and K is the cation part. So when cation loses, when a metal, very strong metal like calcium, potassium or sodium, when they lose electron, and when that electron is gained by hydrogen, the type of bond formed is a electrovalent bond. But hydrogen with non-metals will always form covalent bonds. Remember that. We will come back to that when we are learning our covalent bond part. Now this type of bond that we are talking about is always formed between metals and non-metals. Correct, because metals are givers of electrons, non-metals are receivers of electrons, then they combine with each other through physical forces. So always a bond between metal and non-metal is going to be a electrovalent bond or an ionic bond, and hence hydrogen, like I told you, has characteristics of both metals and non-metal. So when it is close to very strong metals, it can behave like a non-metal, like I told you the example of NaH or sodium hydride, potassium hydride, calcium hydride. But when hydrogen is in the presence of very strong non-metals, it behaves like a metal. What is an example of that? HCl. Here can you see H is in the front. H has taken a different role. We will talk about that role later. HBr, H2O. These are the bonds which are not exactly electrovalent, not at all electrovalent bond. They are a different bond. Alright, moving on, we can say something about electrovalency. What is electrovalency? Electrovalency is the number of electrons which has been given or taken, or which has been exchanged. The number of electrons which has been exchanged to form the ionic bond. So if we take example of sodium chloride, how many electrons are exchanged? Sodium loses one electron, chlorine gains one electron. So what is the electrovalency? It's 1. When we talk about calcium oxide, calcium has atomic electronic configuration of 2882. Oxygen has electronic configuration of 2,6. So calcium loses 2 electrons, it gets an electronic configuration of 2,8,8, it loses 2 electrons, and oxygen, whose configuration is 2,6, gains 2 electrons and becomes 2,8. So how many electrons are being exchanged here? 2. So what is the electrovalency of calcium oxide? It's 2. Remember, electrovalency is the number of electrons which are exchanged. All right, in what type of a bond? Electrovalent bond. So this is a very, very important topic. You have to understand this. And electrovalent bonds are always formed between two ions which have a strong physical force between them. Remember this, the electrostatic force of attraction is a physical force. Now coming to the strongest electrovalent bond. What will be the strongest electrovalent bond? If you talk about sodium and chlorine, sodium is a very strong metal. Why is it a very strong metal? Because immediately it loses one electron and becomes a sodium ion, and that is a metallic characteristic. And chlorine is a very strong non-metal, so it immediately gains that one electron and becomes a chloride ion, and that is called having electronegativity, correct? So when sodium and chloride combine with each other, highly reactive sodium and highly reactive chlorine forms ion and combine with each other, it becomes a very stable bond. Why is it stable? Because two reactive substances are brought together. So two highly reactive substances are held together by a very strong bond. So the most metallic element is cesium and the most non-metallic element is fluorine. So NaCl, even though it is a very strong electrovalent bond, the strongest electrovalent compound present is cesium fluoride, where cesium loses one electron, fluorine gains one electron and forms a electrovalent or ionic bond. Okay, now we are looking at the structure, the orbital structure of formation of sodium chloride. Sodium chloride. So there are two elements that are involved here. So let us look at sodium first. Sodium's electronic configuration is 281. Its atomic number is 11. So how are the electrons going to be arranged in the orbitals? 2 in the first orbit, 8 in the second orbit and 1 in the last orbit. The last orbit will be lost, or one electron will be lost. It will be given away. Why? Because it wants to have 2,8 configuration, which is same as the configuration as its nearest noble gas, neon, and it also has an octet complete. So what happens to sodium? Sodium was 2,8, 1. So sodium loses one electron, it loses one electron and becomes a cation, Na+. Why does it become Na+? Because now after losing one electron, the number of protons are still 11. Atomic number gives you the number of protons or the number of electrons in a stable element. Sodium loses one electron and now it has a configuration of 2,8. So now it has only 10 electrons, but it still has 11 protons. So who has a bigger charge density? It is proton. How many protons more? One proton extra is there. So I have 11 protons and 10 electrons. So I have one positive charge with me. So it becomes a positively charged ion. So sodium has configuration 2,8, 1, but sodium ion has a configuration of only 2,8. Alright. So let us draw the structure of sodium ion. I am drawing the structure of sodium ion, not of sodium metal. Remember this. So sodium, in its first shell, it has 2 electrons, and in its valence shell now, it has 8 electrons. This is the last shell now. And we cannot forget that it also has a charge. So we will show the charge like this. Alright. Next, let us come to chlorine. What happens to chlorine? Chlorine has a configuration of 2,8, 7. So what will this chlorine do? Again, to get chemical neutrality or chemical stability, what is it going to do? It wants to become like its nearest noble gas, or simply you can say it wants to complete its octet. So how can this chlorine complete its octet? It can gain one electron. So here there is one thing that you have to note. It's not necessary that the electron that is lost by sodium is the same electron that will be gained by chlorine. All electrons of all elements are alike. So any free electron available in nature anywhere around the close vicinity of chlorine will be accepted by it. It's not necessary that the electron that is lost by sodium has to be the same electron which chlorine gains. There is no need for that. So coming to chlorine, chlorine will gain one electron. So now how many electrons does this chlorine ion have? The chlorine ion, which we call as chloride ion. Sodium ion is called as sodium ion. The name does not change, but chlorine ion is called as chloride. Alright, so you can simply say chloride. You don't have to say chloride ion, because chloride word in itself tells us that it is an ion. So chloride now has one extra electron, but the number of protons are still 2 plus 8 plus 7, that is 17. Number of electrons will now be 2, 8, 8. So 18 electrons are present. So what will be the charge? One extra electron is present with us now. So the charge will be 1 minus. So chloride ion has a negative 1 charge. Alright. So let us draw the structure of this chloride. So for chlorine, it has 2 electrons in the first shell, 8 electrons in the second shell, and another 8 electrons in its last shell. And since it gained one extra electron, it also has a charge. The charge is minus 1. Alright, so this is your sodium ion and this is your chloride. Is that understandable to you? Now the chemical activity is over. Now the physical activity will begin where we can see the formation of the bond. Another thing, I have drawn the electrons of sodium with yellow and the electrons of chlorine in blue, but this is just for our understanding. All electrons, all protons, all neutrons look alike. Then why is sodium so different from chlorine? Because number of electrons matter. Number of electrons gives it the characteristic property to each element. Remember this. So let us see the formation of sodium chloride. So now one electron is accepted by chlorine. Okay, let us assume in an ideal situation that the electron which is lost by sodium is the same electron which is gained by chlorine. So how will the structure look? Sodium now has 2 electrons in its first shell and 8 electrons in its second shell. And what is the charge? Plus 1. And what about my chlorine? Chlorine has 2 electrons in its first shell, 8 electrons in its second shell. Eight electrons in its second shell, and now I have only drawn 7 electrons. Here I had shown you 8 electrons, but we are assuming that the electrons lost by sodium is the same electron gained by chlorine. So can I draw one electron like this? This is the electron that previously belonged to sodium. Alright, this is just for understanding purpose. This is a theoretical concept. There is no reason why chlorine has to accept the same electron as given by sodium. There is no requirement for that, but this is just for a theoretical understanding. So can I draw the last electron like this? So we can say that this lost electron is gained by chlorine. It has a -1 charge. So now the positively charged and negatively charged ions have come close to each other. So they are going to feel what attraction? Electrostatic forces of attraction. So this is the attraction that they will feel because of the opposing charges, and they will form the bond. This bond is an electrovalent bond or an ionic bond because they have come together by a physical force of attraction between two opposite charges. So this is the orbital structure. Let me also show you the electron dot structure. What is the speciality of electron dot or Lewis dot structure? We only draw the last shell. We don't even draw the last shell. We just show the last shells or valence shell electrons. It's a simpler structure to understand any compound formation. So what will be the Lewis dot structure or the electron dot structure? Na has lost its last shell. So it has no electrons in its last shell. So simply I will write Na, but don't forget the charge. This is your Na. It has lost the last shell. What happened to chlorine? Chlorine has its own 7 electrons in the last shell. 2, 3, 4, 5, 6, 7 and 1 electron donated by sodium. So this is how it looks. 1 minus, and you cannot not show this arrow. This shows Coulomb force. Coulomb force because that's the unit of electrostatic force of attraction. You can simply write electrostatic force. Both mean the same thing. Coulomb is the unit, so sometimes we call it Coulomb force. Alright, so I hope the structure of NaCl is clear to you all. I will draw the structure of MgCl2 now. Okay, now coming to magnesium chloride. Again, magnesium is a metal. It will lose electrons. How many electrons will it lose? Magnesium's atomic number is 12. So let us see. So magnesium's electronic configuration will be 2, 8, 2. So to become like its nearest noble gas or to get an octet state, however you like to remember it, you can. To become like its nearest noble gas neon or to get an octet state, what is the best possibility? To lose 2 electrons. So now magnesium is losing 2 electrons and it becomes a magnesium ion. So now it has lost 2 electrons, it has 12 protons, but it has only 10 electrons. So who has more charge? Protons have more charge by how much? What are the unitary value of the charge? There are 2 units of charge that are extra, 2 units of positive charge. So it will become Mg2 plus and its configuration will be 2, 8. Now we have MgCl2. So magnesium chloride is MgCl2. So how many atoms of magnesium are present or how many ions of magnesium are present? 1. And how many ions of chloride are present? 2. Why does this happen? Let us see. Chlorine. The electronic configuration of chlorine is 287. So each atom of chlorine, I repeat, each atom of chlorine requires only 1 electron to get its octet stable or become like its nearest noble gas, which is argon. So 1 chlorine will only accept 1 electron. Correct? It cannot accept more than 1 electron. So 1 chlorine will accept 1 electron and now it has 1 extra electron, but number of protons are still 17, number of electrons are 18, so it will get a unit negative charge. So chloride ion has 1 negative charge, 1 minus charge, and its configuration is 2, 8, 8. So what will happen now that we are assuming, we are already, I have told you, we are assuming that the electrons lost by magnesium are the same electrons that are gained by chlorine. So magnesium has lost 2 electrons and chlorine only accepts 1 electron. So we will require 2 chloride ions to accept 1 electron each from magnesium. So there will be 2 chlorines accepting 1 electron each from a single magnesium atom or a single magnesium finally when it becomes an ion. So how will the structure look? Magnesium in the middle and 2 chlorines on the side. This is how the orbital structure will appear to us. So let us draw the structure once. So magnesium, in its first shell it has 2 electrons. We are drawing the ion directly, remember this. And in the last shell or the second shell it has 8 electrons. I will draw the last shell for you just to show you how these electrons are transferred, but we will remove that shell later. Now this is the last shell of magnesium from which it lost 2 electrons. So let's say it has 2 electrons over here. Alright, let us draw the chlorines on the either side. This is the first shell of chlorine, 2 electrons. Again, here I am drawing the first shell of chlorine with 2 electrons. The second shell of chlorine with 8 electrons. So 1, 2, 3, 4, 5, 6, 7 and 8. And again the second shell of chlorine over here also has 8 electrons. This is the same chlorines that I am drawing for you guys. So I am just repeating this over here. Alright, 1, 2, 3, 4, 5, 6, 7 and 8. And the last shell has how many electrons? 7 electrons of its own. So how many electrons does it have of its own? 7. So 1, 2, 3, 4, 5, 6 and 7. Same for this chloride. Chlorine 1, 2, 3, 4, 5, 6 and 7. Now what happens is this magnesium, these 2 extra electrons of magnesium is transferred to each of this chlorine. Is that clear? So this electron will go to this chlorine because chlorine can only accept 1 electron. One chlorine atom can only accept 1 electron. And this will go to this chlorine. So let us see what happens. So now what happens is, one magnesium electron has gone to this chlorine and one has gone to this chlorine. So now what happens? Magnesium gets a 2 plus charge because it has lost 2 electrons. This chlorine gets minus 1 charge and this chlorine also gets minus 1 charge. And how are they brought together to form a compound or a molecule? MgCl2 कैसे बनेगा? MgCl2 will be formed by the electrostatic forces of attraction. Electrostatic forces of attraction. Remember, it's a physical force. It's a physical attraction. Chemical process is long done when the transfer of electrons have taken place. Alright, I will also draw the electron dot structure for MgCl2. Remember, electron dot structure is only tested in standard 10. Electron dot structure is not tested in standard 9. But still you should know, it's very easy. So let us draw the Mg first. Mg does not have the last shell. So we won't draw anything. It has lost its last shell. So Mg only with a charge. So it's an Mg ion. Chloride ions. So chlorine has its own 7 electrons in the last shell. 1, 2, 3, 4, 5, 6, 7. This chlorine also has its own 7 electrons. 1, 2, 3, 4, 5, 6 and 7. And it has 1 electron donated by magnesium. So now chloride ion has 1 minus charge. And how are they held together? By a physical force, which is electrostatic force of attraction. Is that clear? Alright, now coming to my calcium oxide. CaO. Calcium is a metal. Oxygen Oxygen is a non-metal. Let us look at the electronic configuration and see how many electrons are donated and accepted by each. So calcium loses 2 electrons. Let's see why. Because calcium's electronic configuration is 2882. 2882. Its atomic number is 20. Its atomic number is 20 and it has 4 shell. The electronic configuration is 2882. Now it wants to get octet stability. It wants to have an octet in its last orbital. So can we say that it wants to become like its nearest noble gas? Who is the nearest noble gas to calcium? Argon. Both ways of remembering it is correct. So it wants to become 2,8,8. So what will it do? It will lose 2 electrons and it will become a calcium ion. It will have 2 positive charges. Why? Because now this calcium ion only has 18 electrons but 20 protons. So who has a bigger charge? Protons. By how much? 2. Coming to oxygen. Oxygen's configuration is 2,6. So to become like its nearest noble gas neon, or to get an stable octet or the last shell to be an octet, it wants to accept 2 electrons. So it will accept 2 electrons, and for theoretical purposes we will believe that these 2 electrons lost by calcium are the ones which are gained by this oxygen. This is completely theoretical. It is not necessary at all, but this is just for the sake of your understanding. So now this oxide has 2,8. So it has 10 electrons, but it has only 8 protons. So who has more charge? Electrons. And by how much? 2. So what will it get? 2 minus charge. Is that clear? Let us see how this molecule is formed. Calcium, first shell, it has 2 electrons. So we are drawing the ion directly. So we have to take that into consideration. First shell has 2 electrons. Second shell has 8 electrons. Third shell has again 8 electrons, correct? The last shell had 2 electrons, both of which were donated to oxygen. So now oxygen has 2 electrons received from calcium. So let us come to oxygen. Oxygen's configuration, oxide's configuration is 2,8, out of which 2 electrons are from magnesium. So first shell has 2 electrons. Second shell has 8 electrons, of which only 6 are its own. The other 2 it has obtained or received from calcium. So we have to draw it in a different color or a different sign. You can't use different colors in your exam. So what we do is, अगर calcium का circle दिखाया है, तो for magnesium or oxygen, for oxygen in this case, you can show a cross or you can show a plus sign. That can also denote your electron. It just has to differ from each other. This is only for the sake of understanding. All electrons look alike. Remember this. So oxygen has 1, 2, 3, 4, 5, 6 of its own, and 2 were donated by calcium. Is that clear? So this calcium has become an ion with 2 plus charge, and this oxygen has also become an ion, an anion with 2 minus charge. So how will they be held together? By electrostatic forces of attraction, or we can say by Coulomb force. It's a physical force. Alright, so with this, all 3 examples of our electrovalent or ionic bonds are complete. These are the examples that you have to study in terms of orbital structure and dot structure. Let us draw the dot structure. Let us not forget it. Calcium has lost its shell. So we do not need to draw the last shell of calcium. Only the charge. And what about oxygen? Oxygen has 1, 2, 3, 4, 5, 6 of its own, and 2 donated by calcium, and it has 2 minus charge, and they are held together by Coulomb force. Alright.